In this video, I'm gonna be talking about clustering. What is clustering? Clustering is the task of grouping data points in a data set. And usually, this data set does not come with data labels for each of the data points. So in other words, there is no target class if you want to use the terminology from classification. Thus, clustering is an unsupervised learning. So you don't tell the algorithm, the class that each data point belongs to ahead of time. So let me demonstrate graphically what I mean. So we have, assuming we have a data set, this is x1 and this is x2 axis, and then we just have a bunch of data points. So we have this data point, and then we have, well, let me keep green. So we have data points like this, data points, then we have other data points like that. So the task of a clustering algorithm is to put these data points into classes, just put them into groups. So a clustering algorithm may say, okay, I think these belong to one group, and maybe these belong to one group, and these belong to another group. Another clustering algorithm may say, oh, well, maybe these belong to one group. However, it looks to me like these belong to one group and this in another group. So what these clustering algorithms are doing are they are defining sort of an additional attribute, So if the clustering algorithm with the orange clustering may say, okay, I'm going to assign 1 to this class, 2 to this class, 3 to this class. So if you belong to this class right here, then we give you a new value, a value for a new attribute we're creating. 1, if you're here, this is 2 and 3 and so forth. But let's not deviate into creating new attribute. Let's just focus on putting the data points into groups, so into clusters. So what does this mean? This means that we have put our data sets into groups. That's what the clustering algorithm does. Anyway, so let's look at a few clustering algorithms. Actually, we're going to focus on one in this video. But before I proceed, I want to mention that most clustering algorithms, so clustering algorithms, I'm going to write it. They usually require that you specify the desired number of classes or number of groups. So in this case, it's 3. All right, let's start with the k-means clustering algorithms. K-means is a famous clustering algorithm. So the k-means clustering algorithm, what's the idea? The idea is this. The idea is that we're given a data set. Given the data set, I'm just going to write yes. Let's say the data set is a data set containing data point x1, x2, all the way to xn. And let's assume that this data set has k clusters. So given that D has k clusters with centroids, and I'm going to explain what centroids are. With centroids mu1, mu1, mu2, all the way to mu k. All right, k clusters with centroids mu1, mu2 to mu k. So the centroids are just the centers of each group, right? You can think of it as the mean of each group. All right, so given this, we want to assign each data point I don't know what's wrong with my handwriting today. It's getting so tiny. All right. Assign each data point xn to, so this goes from x1 to x capital N, right? So assign each data point xn to the cluster whose centroid is closest closest to the data point, to xn. All right. Now, how does the algorithm go? The algorithm is this. The algorithm has the first part, initialization. So initialization is to assign the centroids to k distinct points, right? Just choose centroids. And the centroids, they don't even have to belong to the data set. All right, so assign mu1. So assign mu1 all the way to mu k to k distinct points. Okay. So usually these mu's, they don't have to belong in the data set, but I usually just choose k distinct points from the data set. So that's the first thing we do. K means, so initialization, and then the second part is the expectation part of the algorithm. So we call this the E step. All right. So what does this mean? So for each data point xn, you want to compute the distance so you want to compute the minimum, so let's call it k. Stay with me. Compute k is the argmin, and I'll explain what this means. Argmin j of the norm between the norm of xn minus mu j. Okay? So what does this mean? So it means you want to look at the distance between the point xn and each of the mu j's and take the minimum of those distance. Okay? So this is called a norm. So this is the distance. It could be the Euclidean norm or any kind of norm. So for instance, so let's just focus on this. What's this? Think of it as double absolute value. What does it mean? So I'm going to explain what it means in green. So if I have, say I have a vector, let me say the vector is v, and v is a vector, let's assume our vector just has m values. So v1, v2, all the way to vm, right? The norm of v in this case, I'm going to assume the Euclidean norm is just the square root of v1 squared plus v2 squared all the way to vm squared. So that's what this this notation means. So in this case, you subtract xn, you subtract mu j from xn, right? And then compute the norm this way. So for each data point, you do this for each, you find the distance, which is the norm in this case, the distance between xn and mu j. And you do it for all the mu j's, and then you find the minimum of them. So let me write this. This is the distance between xn and mu j. Okay. So another way to look at it is let me write it this way. So I'm going to say this means that we want to find the mu k. You want to find the mu k such that xn minus mu k is the minimum distance, is the minimum of all the xn minus mu's. So this would be xn minus mu1, xn minus mu2, all the way to xn minus mu, I think mu k, yeah, that's what we have. All right, so if we find such k, that means that xn belongs to cluster k. I'm going to be careful now because I'm using a lot of k's. All right, so this is capital K. All right, remember that there are k's, k, capital K mu's. All right, mu1 to mu capital K. All right, so this little mu k is just one of the mu's from mu1 to mu capital K. I guess here I used j, but it doesn't matter. Okay, so this means that xn belongs to cluster k, cluster little k. So that's what the expectation step is. And now we have the maximization step. Maximization, let's call it the M step. All right. So what is this step all about? So we want to recompute. Once we do this, we have to recompute each mu j. All right, mu j, and remember j goes from 1 to k, capital K. So basically compute the centroids again. And the centroids are just the mean of each of the groups now. So mu j is simply the mean of all the xn's such that xn is in cluster j. All right. Okay. So and also I use k here, and here I'm using j. It doesn't really matter. And then the fourth step is to repeat E step and M step until the means no longer change. And then what are the means? These are mu1, mu2, all the way to mu k. k no longer changes. Each of them, none of them changes. Okay, so that's the algorithm. So, and k-means has a few properties. So, properties of k-means clustering. So the first property is that it converges, right? So it converges to the means mu k, k from 1 to capital K, to the means minimizing j is equal to n from 1 to capital N, k from 1 to capital K, of all the norms. All right. So you want to compute all the distances. Assign the function j to all the sum of all the distances between each of the data points and each of the means, right? So this algorithm actually converges to the means that minimize this quantity right here. What's another property? Actually, the result is sensitive to the initial means, All right, you notice here that I'm using the word mean and centroid interchangeably. Please don't get confused. All right. However, it has some advantages. Let's look at some advantages of the k-means algorithm. So the first advantage is that it's actually simple compared to some other clustering algorithms. And then it can actually combine, more than one distance measure. So over here, I used the Euclidean mean, but you can use any other kind of mean, right? Oh, sorry, the Euclidean norm, but you can use any other kind of norm. All right, what else? What else can I say? Oh, let's talk about the drawback, if I can remember. So drawbacks, it performs poorly on data sets, on data set D with overlapping regions. What else? It's not robust to outliers. It's not robust to outliers. So that's all I can think of. So let me do a quick overview. So we have a data set x1 to xn, capital N right here. All right. And let's assume this data set has naturally has k clusters in it. And each of the means of the clusters are mu1, mu2, mu-k. So the idea is to assign each data point to a cluster whose centroid is closest to xn, all right? So what does this mean again? So we have let's say we have this. So let me go back to actually let me draw it here. Okay. So we have data points here. We have data points here. And we have data points here. Naturally, this has 3 clusters. So we can, at the end, maybe the means, the centroids are here, here, and here, right? So we want to be able to do clustering in such a way that each data point is grouped is put in a group where it's closest to its centroid, to the centroid of that group. Basically, that's what it is. All right, the initialization is to choose k random data centroids, group centroids. It's not that random. You have to think about. You can think about. There's an art to it, but if you don't know what to choose, just choose random centroids. I usually choose a centroid from the data set, right? Like k of them. Then the expectation step is now for each of the data points, right? If I want 3 clusters, if I'm assuming 3 clusters, I want 3 clusters, I go through my data set D, I take the first data point x1, I compare it, I look at each distance from each of the centroids, then the distance that is the shortest, I assign that data point to the group whose centroid gives the shortest distance. All right, that's what the expectation step is. Then the maximization is, after doing that, I recompute the centroid. How do I recompute the centroid? I look at the groups I've created and I find the mean of each of the group that become, all these means, they become the new centroids. And then what do I do now? I repeat the E step and the M step until the means no longer change. All right, that's it for k-means clustering. Bye.